How California dunes help map Mars' shifting sands. Imagine this. The vast wind-swept dunes of the California desert are not just a scenic wonder, but a treasure trove of information for scientists studying Mars. The Algodones Dunes, stretching across the borders of California, Arizona, and Mexico, are providing invaluable insights into the Martian landscape. By examining the dunes and sand patterns in this region, researchers like Lauren Berger from Texas A&M University are unlocking secrets about how wind shapes both Earth and Mars. In a recent article for Stace.com's Expert Voices, Berger delves into how studying Earth's dunes can help us understand the complex and ever-changing sands of Mars, where dust storms frequently sweep across the surface. This research is crucial for future human missions to Mars, offering insights into the planet's wind patterns and the potential hazards posed by its shifting sands. But here's where it gets controversial. While some argue that Mars's thin atmosphere makes its wind patterns less significant, others believe that understanding these patterns is key to ensuring the safety of future missions. What do you think? Understanding aeolian bedforms, bridging Earth and Mars. Aeolian bedforms, such as sand ripples and dunes, are features shaped by the wind and can be found on both Earth and Mars. On our planet, these wind-driven patterns are common in deserts and other arid regions. Mars, with its cold temperatures, low pressure, and dusty atmosphere, also bears similar formations. Lauren Berger's research focuses on two main types of aeolian bedforms, sand ripples and dunes, created by wind. By studying these structures on both Earth and Mars, Berger aims to develop a comprehensive understanding of the forces that shape these landscapes. On Earth, these features are often shaped by a mix of strong winds and sand size, while on Mars, the thin atmosphere and less intense winds provide a different, yet still fascinating, challenge for planetary scientists. And this is the part most people miss. The unique conditions on Mars mean that the wind's ability to move sand is vastly different due to the weaker air pressure. However, the patterns and shapes of dunes and ripples on Mars provide vital information on the planet's atmosphere and wind behavior. By analyzing similar patterns on Earth, researchers can gain clues about the Martian winds, how fast they blow, how they interact with sand, and how often dust storms might reshape the surface. This comparative study allows scientists to simulate and predict how the same patterns might emerge on Mars, ultimately helping in preparing for long-term human exploration and habitation. Field research at the Algodones Dunes, a closer look. In the winter of 2022, Lauren Berger and her research team embarked on a field study at the Algodones Dunes in California. The region, known for its vast and dynamic sand fields, provided an ideal location for observing the finer details of coarse-grained sand ripples. Using GPS, drones, and traditional geological tools like trowels and sample bags, Berger and her team meticulously measured the size, height, and spacing of these sand ripples. These ripples, which can range from small to large, Berger also noted the crucial role of physical fieldwork in geology, emphasizing that it often involves unexpected challenges, such as the occasional need to dig out a stuck vehicle. Despite these obstacles, the data collected in the desert promises to contribute significantly to the understanding of both terrestrial and Martian sand formations. The role of remote sensing in mapping Mars. One of the most exciting aspects of this research is the use of remote sensing technologies to analyze the sand formations. On Mars, where direct access is impossible for most researchers, images from the Mars Reconnaissance Orbiter, MRO, provide invaluable data on the planet's surface. These images capture dunes and other aeolian bedforms across the Martian landscape, giving scientists a comprehensive view of how the planet's wind interacts with its sandy surface. By combining this remote data with on-the-ground measurements from Earth, Berger and her team are building a more detailed and accurate database of compound dunes on Mars. Compound dunes, which feature multiple layers of sand dunes formed at different times, are particularly interesting to scientists. These formations could hold the key to understanding long-term environmental changes on Mars, such as shifts in wind patterns or atmospheric conditions. By using drones to photograph dunes on Earth and comparing them to images from Mars, Berger is contributing to the creation of the first database of compound dunes on the Red Planet, which will be essential for planning future missions. The importance of understanding Mars' shifting sands for future missions. Understanding the nature of Mars' shifting sands is crucial for planning future missions to the planet, especially manned ones. The wind on Mars can be deceptively powerful despite the planet's thin atmosphere, and dust storms can cause significant disruption. Some of these storms are so large they can cover the entire planet, which poses a serious risk to landing sites, rovers, and potential habitats. For future astronauts, understanding where these dunes form and how they behave will be essential in choosing locations for exploration and construction of bases. Berger's work aims to pinpoint the safest areas on Mars, considering how dunes might shift over time or even become hazardous during a dust storm. The data from these studies will assist in creating detailed maps of Martian wind patterns, helping space agencies like NASA avoid regions with the most dangerous sand movements. As human missions to Mars become a reality, understanding the planet's surface features, particularly its wind-driven landscapes, will be pivotal in ensuring both the safety and success of the mission. But here's a thought-provoking question. Should we prioritize exploring the most scientifically interesting areas of Mars, even if they are potentially hazardous, or focus on safer but less intriguing locations? Let us know your thoughts in the comments.